For 60 years we've traveled to other worlds using the same basic principle, a massive short-lived chemical burn to escape Earth's gravity, followed by a long, unpowered coast through the void. It's a reliable method, but it turns a trip to Mars into a grueling 6 to 9 month marathon. But what if we could change the rules of interplanetary travel? What if we could push continuously, accelerating for the first half of the journey, and then flipping around to decelerate for the second? This is the promise of continuous thrust, a concept that could reshape human spaceflight sooner than you think. Am I the only one that didn't know? Nuclear rockets could cut months off a Mars trip. Nuclear thermal rockets, or NTRs, use a fission reactor to superheat a propellant like liquid hydrogen, creating 2 to 3 times the efficiency of chemical rockets. DARPA and NASA are already building a demonstration engine called Draco, set to fly in the late 2020s. And that's stub. And plasma drives could cut months off a Mars trip. This is nuclear electric propulsion, or NEP. A compact megawatt-class reactor generates massive amounts of electricity to power ultra-efficient plasma thrusters. These engines, like Hall thrusters or Vasimmer, use electromagnetic fields to accelerate ionized gas, producing a gentle but unrelenting push. So how does this get us to Mars in a month? With a tiny acceleration of just 1 or 2 millimeters per second squared, less than a 10,000th of Earth's gravity, a ship can reach incredible speeds over time. The catch? It requires immense power, which is why compact nuclear reactors are the key. Continuous thrust means faster trips, less time exposed to deep space radiation, and far smaller life support burdens. The truth is, labs and agencies are testing the pieces right now. NASA is advancing high-power Hall thrusters for the Gateway space station, while private firms are hitting new milestones with VSIMR engine tests. Of course, challenges remain. Engineers must solve hydrogen boil-off for NTRs, manage thruster erosion on long-duration burns, and design massive radiators to shed waste heat in a vacuum. But these are engineering problems, not physics barriers. The roadmap is clear. First, ground tests and safety certifications through the 2020s and 2030s. Then, uncrewed flight demonstrations to prove the technology works in space. Once proven, these systems will power fast cargo missions, and finally, crewed transits. It's not fantasy, it's a countdown. Mars in a month. Quieter, closer, and finally within